Yeah. So, hi all. Good evening and welcome back to the 10th week of TA Live sessions for AI SMPS. So, can anyone just quickly confirm whether I'm audible and if my screen is visible? Okay, thanks for confirming. So, yeah, this week we'll be discussing questions from week 10, which will cover um, some OPS 5 based uh, content and also rule based systems. So yeah, we'll be covering those topics, and like I have been saying in the previous weeks, this week 10, and the upcoming 2 weeks, week 11 and 12, are relatively easier. So yeah, I encourage all of you to try to score as much as possible in from content related to these particular weeks. Okay, so without any further delay, I think we can get started. So this is the problem statement for the first couple of questions that we are going to deal with. So here we are given two rules, okay, and a working memory. Okay, the rules are on the left hand side and the working memory is on the right hand side. Um, we have a production system and we'll allow it to run to completion until no more rules can be fired. Okay, so if we reach a situation where no more rules can be fired, we will halt the and the whole production system will terminate. Okay, and each rule has certain components. So the name of the rule is given by this rule 1 or rule 2. Okay, each rule has some prerequisites. Okay, for example, rule 1 has two prerequisites or preconditions, which is that a natural number denoted by the variable num should be greater than 1 and that num should be even. And if these two conditions match, then we will add a new fact to our working memory or add a new element to our working memory, and that element would be the half of the number n. Okay, and similarly rule 2 says that if we have a number n which is greater than 1 and if n is odd, we will add a new number or a new element to the working memory which will have the value 3 times the number plus 1. Okay, so it's a simple production system, simple rules, and we are starting with this working memory element where we are given a number which has a value equal to 13. Okay, so yeah, I'll let you try to go through this rules and working memory and try to solve this on your own as well, and then we will discuss what are the steps involved. Okay, so remember you have to run this until you reach a point where no more rules can be fired, and then your system will halt. Okay, so has anyone been able to complete or have any partial solutions as well? Okay, so let's go over the problem once more and see if we can try to solve it intuitively first. Okay, so like I was saying, we have two rules. The first rule has a name, rule 1. It has these preconditions, and if these are satisfied, this output will be added to our working memory. Okay, similarly rule 2 has this name, rule 2 has these preconditions, and if these are met, this output will be added to the working memory. Okay, so currently our working memory consists of one element which is denoted by this timestamp of 101, and we know that there's a natural number which has value 13. Okay, so we will see which rule can be selected or fired from amongst rule 1 and rule 2. We know that n is greater than 1 because 13 is greater than 1, but n is not even, right? Because we have 13 which is an odd number. So we will apply rule 2. And what does rule 2 say? That we need to add 3 into n plus 1. Okay, so in our case this will be 3 into 13 plus 1, which will give us 40. Right, so 40 will be added to our working memory. I am not writing the whole syntax. This should be nat num 40 and 102, right? But you can do that on your own. We'll just try to solve it intuitively first. Okay, so now we'll subject 40 again to these two rules and see which of them can be used. So 40 is now an even number, so and it's also greater than 1, so rule 1 will be fired, and we will have the half of 40 added to the working memory, which is 20. We will repeat the same process until we reach a state where we have to halt or no rules can be fired, right? So after 20, 20 will be half to 10, then we will have 5. Now 5 is odd again, right? So again rule 2 will be fired, which will add for us 16, right? 5 into 3 plus 1, 16. So 16 is even again, so again rule 1 will be fired. So 16 by 2, 8 will be added, then 4 will be added, then 2 will be added, and then 1 will be added, right? So now we reach a state when we have a value of 1 in our working memory. None of the rules can be fired, right? Because one of the preconditions for both the rules is that n should be greater than 1, but we have an n which is equal to 1. So at this point we know that none of the rule 1 or rule 2 can be fired, and we will halt the system. Okay, so this was an intuitive way of trying to solve it. If we have to be more formal, then this is how we will denote the whole production system procedure, right? We will start with the working memory element that we had. Okay, then we will add a new fact that will be a result of firing rule 2 with the timestamp 101, which is the input to rule 2 will be the working memory element denoted by the timestamp 101. Okay, this will result in the addition of an element with timestamp 102, okay, which is having a value of 40, and will continue to fire up and until we reach timestamp 110, where we have a value of 1, and at this point no more rules can be fired and we stop or halt our production system. Okay, so I'll leave this on here for a while and I'll let you try to go through it and convince yourselves of the flow or the procedure of the solution, and then we can move to the questions based on this particular setting that we just saw. Okay, so there's one doubt in the chat box. If both rules are satisfied, how do we decide which rule to use, right? So that's a good question. And because we started off with an easy example, in this example we didn't face a situation where both the rules were applicable, right? But we can very well have a situation where not just two, but more than two rules or multiple rules can be applicable at the same point of time. So at that point of time, what we will do is we will have a set of rules that we will add to our conflict set. Okay, so we will have a set called conflict set that will contain all the candidate rules that can be fired at a particular instant of time. Okay, and then we will have to adopt certain strategy to select one of those rules to fire next. Those strategies could be something like specificity or recency, some of which we will see in the upcoming questions, okay, and others you can find in the lecture videos. Okay, so the whole point is that if you have a situation where more than one rules can be fired, those rules will be will be added to your conflict set, and we will adopt a conflict resolution strategy to try and select one of those rules to fire in the next instant. I hope that addresses your doubt to some extent. Okay then, I hope the solution for this problem was clear. Let's move on to the questions and see if we can solve them. Okay, so the first question, based on what we just saw, is that when the production system is in flight or when it's running, after the first two rounds of firing, the newly created working memory element, which is the element having timestamp 103, is which of the following? It would be C, right? Because we saw that the first time it was fired, we ended up with a value of 40. The second time it was fired, we ended up with a value of 20, right? So the working memory element with timestamp 103 would have a value of 20. Yeah, sure. Mm-hmm. Sure. So essentially what we're trying to do is we are given a working memory, okay? We are given a fact or an element in the working memory, and we have two rules that can be applicable, okay? Each rule has a name, has some preconditions, and if those preconditions are satisfied, we will the rule tells us that we will add certain facts to our working memory, okay? For example, rule 2 says that if we have a value n that is greater than 1 and if n is odd, we will add the number 3 times n plus 1. Okay, so that is what we did over here. We had a 13 which is greater than 1 and which is odd, so we added 3 into 13 plus 1, which is 40, to our working memory. Okay, more formally put in over here, and we will repeat this process to see which rule 1 or rule 2 can be fired. We will fire that rule or apply that rule, and we will continue this process until no more rules can be fired, that is none of the preconditions of either of the rules are met, and then we will halt the process. Okay, that is a simple problem we have at hand. And yeah, so as one of your colleagues answered, the newly created working memory element at timestamp 103 would be 20. Okay, any doubts there? Okay, that's great then. Let's see what the next question is. The next question tells us when the production system is in flight or when the production system is running, after rule 2 is fired for the second time, the newly created WME or working memory element is which one? So here we have to report the working memory element that will be added at timestamp 106. So we can see here rule 2 was fired for the first time. Then here rule 1 was fired, again rule 1 was fired, again rule 1 was fired, and here rule 2 was fired for the second time, right? So at this point of time, we will be adding this particular element to the working memory, right? So the correct answer in this case would be C again, that num16. Okay, I hope that was clear again. Let's look at question 3. So when the production system is halted, we are asked in total how many times was rule 1 fired. Okay, so let's go back to our solution again, and can someone tell me how many times was rule 1 fired? So as some of you might have already seen and answered as well, rule 1 was fired 7 times, right? We can verify this from here. This is 1, 2, 3, 4, 5, 6 and 7 times rule 1 was fired. So when you fire a rule, you essentially mean that you apply that rule. Okay, this is just a jargon for the production systems. Okay, let's now look at question 4, which asks us, after the production system has halted, how many times was rule 2 fired? And that would be 2, right? Because we see that rule 2 was fired only 2 times. That's right. So let's check the solution, and it is 2 times. So I think this concludes a very basic example related to rule-based systems and production systems that we just saw. Okay, now let's move on to a slightly more involved example. Okay, so now we'll be using a different rule and a different set of working memory elements to solve the next couple of questions. Okay, so we are told that a working memory has some 4 elements, okay, that are arranged in the increasing order of timestamp. Okay, for example, the first working memory element tells us that the date today is 27 September 2021. Okay, the second timestamp tells us that a person with an ID Amy is eligible. Similarly, the third and fourth timestamps tell us that a person with ID Joy and Roy respectively are eligible as well. Okay, and the rule tells us that there is a rule, the name of the rule is P vaccine 1A. Okay, the preconditions for that rule are that there should be a person by the ID of X, right, who is eligible, and the date today should be Y. Okay, if these two conditions are satisfied, we can add a new fact or new element to the working memory containing this information. First dose ID X, next Y plus 30 days. So what this translates to in natural languages is that a person with ID X has now received the first dose and of let's say a vaccine, and the next dose for that person is now scheduled after Y plus 30 days. Okay, so if today's date is Y, then and the person is eligible, and the person will be receiving the first dose of vaccine, and his or her next dose will be scheduled after 30 days. So that is the information that this P vaccine 1A rule conveys. So any doubts in the rule or the working memory that we have in this problem? Okay, if not, then that's great. Let's now move on to the questions. Okay, so this question now asks us, it doesn't ask us to solve the problem as of now. We first have to understand the structure of the rule given to us, okay, or the elements or the constituents of the rule to understand how exactly a rule is formed. So this question asks us how many classes are being referred to in the given rule. Okay, So I'll go back to the rule over here and I'll let you think over it, and you can feel free to write your answers in the chat box. Okay, so we have a couple of answers in the chat box already. So there's a confusion between whether there are 2 classes or 3 classes or 4 classes, right? So to resolve this, let's go over the slide that contains some information on the different elements of a rule. Okay, or not just a rule, but just any working memory element. Okay, so you can find this slide in the lecture slides as well, but for now, so any working memory element first of all will have a timestamp. Okay, that will denote the time at which it was added to the working memory. Okay, so in our case we saw that we had some timestamps denoted by 100 and 100 and 200 and 3 and so on. Here we have timestamps denoted by 1 2 3 4 5 6. Okay, and there is no particular nomenclature for that. You can start with 1, you can start with 101, anything that works or anything that is given to you in the question. Okay, next we have each element is made up of a one or more class names. Okay, so for example here next is the class name. Okay, anything that is followed by this upward arrow we call that an attribute. Okay, for example rank is an attribute. Okay, and each attribute can take a value which will be followed by the attribute. Okay, so here the first element translates to a class name next has an attribute rank with a value 1. Okay, the second element translates to for class total marks there is an attribute student with a value Sangeeta, another attribute marks with a value 97, and another attribute rank with value nil. So what this essentially means that in the class total marks, a student named Sangeeta has marks 97 and the rank of Sangeeta is not yet decided, so it is nil. Okay, so this is how you can read a particular working memory element. If we have to take another example, let's say the number timestamp 5 that we have a class name array that has an attribute named index with value 1 and another attribute value with value 29. So what this means is that we have a class array whose index 1 contains the value 29. Okay, with this in mind, let's go back to the rule that we had. Okay, so here we will have this will be the name of the rule. Okay, now let's break down the different information given to us in the rule itself. Okay, so the first element that is given in the rule is this one. Okay, so here eligible would be the class, sorry about that. Okay, id would be the attribute and x would be the value that this attribute will take. Okay, similarly today will be a class, date will be an attribute, and y will be a value that this attribute date will take. Okay, another informational element given to us is this one, where first dose is a class, id is an attribute that takes a value x, and next is an attribute that takes a value y plus 30 days. Okay, so this is what we can gather from the rule given to us. Okay, so how many classes did we encounter in this rule till now? 3. That's right. So here we have 3 classes based on the rule that is given to us. So let's go back and check the question that we had. How many classes are referred to? And the answer would be 3 classes. Okay. I hope that was clear. Okay, thanks for confirming. Now let's move on to the next question. Okay, so remember I was talking about something called as a conflict set. Okay, so this is where the question regarding multiple rules being applicable comes up. Okay, so now what we have to do is, I'll switch back to this rule and working memory slide that we have, and I'll let you try to decide or find out which pair of rule and working memory element can be fired together. Essentially, what you have to do is, so this is the rule name, right? P vaccine 1A. So you have to write a pair P vaccine 1A, and along with which elements of the working memory can this rule be used to produce a new element that can be added to the working memory. Okay, and how such different combinations of rule and working memory elements can we have, given this information that is there on your slides right now. Okay, and there will be multiple rules that may be present or may be applicable at this given point of time. Okay, so let's first form our conflict set, and then we will discuss how to resolve the conflict in the conflict set. Okay, so I'll let this stay here for a while, and then we can discuss. Okay, any guesses on what the conflict set could be constituted of? Okay, which of the working memory elements do you think can be tell me one combination of the working memory elements that can be used with this rule. So remember the two preconditions that we have in the rule. Okay, we must have some eligible ID of a person, and we must have today's date as something. That's right. So 101 and 102 could be one combination of working memory elements that could be used with this given rule P vaccine 1A. Can any other combination of the working memory elements also be used? That's right. So 101 combined with 102 can be used, 101 and 103 can be used, and 101 and 104 can also be used, right? So we will have three different elements in our conflict set. Okay, so the first would be P vaccine 1A. I'm not writing the whole thing. Okay, I'm just writing this. This is the name of the rule, and this can be used along with 101 and 102. This can also be used along with 101 and 103, and similarly this can also be used along with 101 and 104, and the result of each of these will be different, right? The result of the first one would be that Amy has received the first dose of vaccine, and the next dose of vaccine for Amy is scheduled on 27 September plus 30 days. Okay, similarly this one would produce an output or a new element that would say that Joy has now received the first dose, and the next dose of Joy is scheduled for 27 September plus 30 days, and similarly for Roy in case of the third rule. Okay, so this is an example of what a conflict set would look like. Okay, and the conflict over here is among which of these rule and working memory element combinations to select for applying or firing. Okay, and now there are different ways to resolve these conflicts. Okay, this is a very simple example because all of these elements of the conflict set, each of these can be fired in equally likely. Okay, because none of these are very specific or very you can actually apply different strategies. You can actually apply recency over here and try to see which of these would be fired next, but then I will leave that for the next problem at hand that we have, because there it will be easier to explain and also for you to understand. Okay, so basically what I wanted to motivate is an example of what a conflict set would look like. So I hope that is clear, and now let's move to the questions we had. Yeah, there was a hand raise. Any questions there? Yeah, this one. Mm-hmm. Mm-hmm. That's right. Uh, okay, so yeah, so I understand your question. So try to think of this in terms of pattern matching. Okay, so let's say this is our working memory element. Okay, our whole working memory, and these small uh, structures over here are the different working memory elements. Okay, what a particular rule will try to do is, let's say this is our rule over here that has precondition 1 over here, P1, and then precondition 2, and if these two are satisfied, then a rule will fire and it will add some output O1 to our working memory element. Okay, so the way this rule will work is it will search through the working memory to match the pattern of P1 and P2 independently. So first it will try to find an element that has a pattern matching P1. Let's say it found this one. Okay, then it will find an element that has a pattern matching to P2. Let's say it found this one. Okay, now that this has found two patterns that match the preconditions of the rule, this working memory will get transformed. Okay, and along with the previous working memory elements that were there, a new output will be added to the working memory, which will be the new element that we just produced. Okay, so if we have to apply this logic to what we just saw, what this rule will do is it will try to match the pattern of eligible ID X with the working memory that it has, and that will match with 102 alone, right? And it will also match with 103 and 104 independently. Okay, so basically what this means is there are three candidates, three candidate values for this X over here. X could be replaced by Amy, Joy, or Roy, right? And it will also try to match the pattern for this today date Y, and it will see that there is one such pattern, and Y could be replaced by this 27 September 2021. Okay, so now that it has found an equivalent pattern for each of the preconditions, it will have three different configurations in which this rule could be added to our conflict set. Does that clarify your doubt to some extent? Yes, that's right. The patterns are matched independently, and then yeah, and if all the preconditions are met, then we can fire the rule or apply that rule to add new elements to the working memory. Okay, sure. Okay, so let's go back to the question that we had, and this question asked us which of these following rule and working memory element tuples, you can think of tuples as I hope you know what tuples is, but just to make it clear, you can think of tuples as a combination of rule and different working memory elements put together, like we had, right? Something that goes beyond pairs. Okay, so which of the following rule and working memory element tuples will be present in the conflict set? Okay, so which of these do you think would be part of the conflict set based on the discussion we just had? Okay, so I see some of you have already answered, and that would be B, C, and D, right? And so here is another point that I kind of missed and should tell you right now. Ideally, we should report the working memory elements in descending order when we are reporting a rule WME tuple, right? So when I wrote this, I wrote 101 first. While as per our understanding, both are same, but it's ideal to write the one with a greater timestamp before the one with the lesser timestamp. Okay, so 102 comes before 101, 103 comes before 101, and 104 comes before 101. Okay, why this is so, or how this will help us in some conflict resolutions, for example in recency, we will see that in the next few questions. Okay, but just make a note of that. So I hope this was clear. Any doubts till now before we move on to the next question? Okay, that's great. Now let's look at the next question, which is also dealing with the current problems. It says that how many working memory elements will be present in the working memory after 2 cycles of execution. Okay, so assume that you had some conflict resolution strategy. Okay, any of them. We are not going to discuss which of them right now, but assume that you applied some strategy and that gave you sorry, which rule to fire next. Sorry, and you repeated that 2 times. So how many elements will be there in your working memory? B, that's right. So as many of you answered in the chat box, we already had 4 elements in the working memory, and the moment one of these rules is selected to get fired, right? One of these rule and working memory element tuples is selected to get fired, another element will be added, 105, and the second time it is fired, 106 will be added, right? So total number of elements will be 6 now. Yeah, there was a hand raise. Mm-hmm. 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 Yes, so let's say you mm-hmm. Mm-hmm. Yes, it will be like that. So suppose our conflict resolution strategy told us that we will use 101 and 102 to fire our rule. Okay, so 105 would be first dose, ID would be Amy, and then next would be 27 September plus 30, whichever that date would be, that date would be added over here. So that is, this is how 105 would be looking like. Okay. Exactly, that's right, Khalid. Make means add that new element to the working memory. Yeah. Okay. Any other questions in this problem before we move on to a slightly more involved problem? Okay, that's great. Now let's move on to the next couple of, yeah, sure, sure. This this one, this one. Uh-huh. Mm-hmm. 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 The pair, you mean the pair of 101, 102 versus 101, 103, right? Uh-huh, okay. Yeah, so that is the concept behind a conflict set. So we randomly decided, based on some hypothetical strategy, that we will fire 101 and 102. Okay, that will add Amy and so and so information to our conflict, to our working memory. But we could have very well selected 101 and 103, in which case 105 would be formed by first dose ID. This, instead of Amy, this would be Joy. Uh-huh. Yes. Mm-hmm. Yes. Mm-hmm. Yes. Mm-hmm. Hmm. Mm-hmm. So at the stage of selection of the pair itself, we are having different possibilities. Okay. And depending on which possibility we want to go ahead with, we will supply only that value to eligible ID X and today date y. Okay. Make is make is not pairing anything. Okay, pairing is done by us when we are applying the production system. Because that is how our preconditions of the rule are framed, right? We have two preconditions in the rule, right? So we need to have different possible pairs of precondition that we could apply to our rule. Okay. Exactly. Mm-hmm. If so, you mean to say that if we had so no, rule name is at the top. This is the rule name, P vaccine 1A. These are the preconditions for that particular rule. Okay, so suppose we had some rule that had three preconditions. Here we had two, right? Suppose we had three. Okay, let's say P1, P2 and P3, and this would result in some output, let's say O1. Okay, this is a hypothetical example, and let's say our working memory consists of different elements, and because we have three preconditions over here, and let's say multiple of these combinations could be applicable, our conflict set would consist of, let's say, rule 1 with, let's say, 101, 102, 103. Hypothetically, let's say this is one possible combination or three tuple that we have. Another possible combination could be 101, 104, 105. Okay, so like in the previous case we formed two tuples or pairs. Here we will form three tuples. Okay, so it all depends on how many preconditions we need to have satisfied. Even if the class name of two of the preconditions is same, they would take on different values, right? Hmm. 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 That's right. Yes. Blindly you can take three, because each of the precondition has to match with certain working memory element. We cannot have a one to many or many to one mapping. We need to have a one to one mapping between each precondition and each working memory element. Yes, that's right. Okay. Thanks for your question, Satish. I think it was an nice intuitive question. Okay. So, coming back to the next problem that we wanted to solve. Um, so we still have to solve the problem of who gets the first dose of vaccine and so on, so and so. But here we saw only one rule over here, right? We will see more rules in the coming example, and we will put that in the framework of what we will call the RateNet. Okay, so RateNet is a way to represent the different rules that we have, and the different preconditions that those rules would intake, and the different outputs those rules would give us. Okay, so bear with me while I go through this information given to you. Okay, so represent the following eligibility conditions for COVID vaccination in the OPS 5 like language. Okay, those who are eligible or in the high risk category will get the first dose of vaccine. Okay, think of these statements as different rules. Okay, those who are eligible or in the high risk category will get their first dose of vaccine. This could be one rule. The second dose is given 30 days after the first dose. This could be another rule. Those with comorbidity factor in age 12 or more are in the high risk category. This could be another rule. Those who are 40 years or older are eligible for vaccination, and these are the different ways you can formulate the rules given to you. Okay, and what a RateNet would do is it would have different kinds of nodes, alpha nodes and beta nodes. this is what array net would look like. Okay, so you have a class at the first. Okay, so all the beta nodes are marked with the yellow color. Okay, and all the other purple or slightly purplish nodes, they are the alpha nodes. Okay, and they could consist of class name, attribute name, or the attribute value. Okay, for example, let me shift to the Jamboard and try to explain this more clearly to you. Okay, so if you follow this particular line, okay, this and this, okay, so what this tells us that if the first dose, okay, for a person with ID X, if a person with ID X already has a first dose and the next dose of that person is scheduled on date Y, and if today happens to be date Y, okay, then we will fire this rule, which is, now we will say that X now has second dose of vaccine. Okay, so do you follow the way we combine the different preconditions of the rule and the output of the rule to form this elements of this network? For this simple example that we just saw, is this clear, or is there any doubt about how we framed this? Okay, that's great then. Thanks for confirming. So this was for one of the rules. Okay, let's have a look at all the rules one by one. Okay, let's say for this rule, look at the incoming arrows to that rule. Okay, let's use a different color now. Let's use blue. Okay, so this has coming edges from here and here. Okay, and what that tells us, let's have a look. So this tells us that if today is date Y, okay, and if a person with ID X is belonging to the high risk category, then we can add the information that first dose for this person X has first dose, and the next dose is for this person is scheduled after 30 days. Y plus 30 days. Mm-hmm. No. So which node are you talking about? Let me just. This one? Yes, this is a beta node, and this basically represents a rule that produces this output. Second dose for a person named ID. Yeah, so was that the query or anything else you would like to ask? That's right. So beta node, you can think of beta node represents the rule, and the product of that rule or the output of that rule is what is second dose. Okay, so that was the second rule that we saw. Let's think of the third rule now. So this has incoming edges from here and here, and what this tells us is that if today is date Y and if a person X is eligible, then we make that X has first dose of vaccine and next dose of vaccine for this person is scheduled after 30 days. Okay, which is what is given over here. Now let's look at another rule. So this is another rule. This has information coming from here and all the way from here. Okay, so this tells us that if a person with ID X and the health of that person with ID X is known to have a comorbidity is equals to present, and if the person with ID X has age greater than equals to 12, okay, which is coming from this point over here, then we mark this person as having a high risk. Okay, similarly, let's look at information coming for this particular rule from here, here, and here. Okay, so what this tells us is that if a person with ID X, which has a class worker, and um, a type of this person is FLW, which is a frontline warrior, you can think of it that way. Okay, and the age of the person is greater than 12, and if the person's age is also less than 40. Okay, so there are two restrictions with respect to age. One is greater than equals to 12, one is less than 40. If all of these are met, then we can say that X is eligible for a vaccine. Okay, and the final rule tells us that information coming from this particular source, this tells us that if a age of a person with ID X is greater than equals to 40, then directly that person is eligible for vaccination. Okay, so this is the different kinds of ways we have represented the different rules given to us through this network system. Okay, and this is called the RetainNet. So first of all, is the setting of the RetainNet clear? How we define the rules and how each of the rule takes in information from the different elements of the alpha nodes as its preconditions, and how it produces the different outputs. So any doubts over there? Yes, this is the diagrammatic representation of the previous page. Let's match that. Okay, so yeah, so here the first line tells us that those who are eligible or in the high risk category will get their first dose of vaccine. Okay, so this can be broken down into two parts, right? Those who are eligible will get their first dose of vaccine, and the second part could be those who are in the high risk will get their first dose of vaccine. And if we translate that to the network over here, so what was one of the conditions that was given to us? Those who are eligible will get their first dose of vaccine, right? So that comes from this B3 rule over here, right? Those who are eligible will get the first dose of vaccine, and then the second part was that those who are at high risk will get the first dose of vaccine. That is represented by this particular point over this particular element of the RetainNet. Let's go back to the other information given to us. The second dose is given 30 days after the first dose. Okay, so the second dose is given 30 days after the first dose, so that is represented by this part of the RetainNet. Let's go back and check again. Those with comorbidity factor and age 12 or more are in the high risk category. This is represented by those who have comorbidity through this path, and those who have age greater than or equal to 12 through this path, they can be categorized into high risk. Okay, similarly, those who are 40 years or older are eligible for vaccination, which is coming from this part. Okay, those who are 40 years or older are eligible for vaccination. And let's verify the last piece of information given to us, which is frontline workers who are 40 years or below and below 40 years and greater than 12 years are eligible for vaccination. That is represented by this part of the RetainNet. So is the mapping clear? The preconditions are different. So R5 tells us that a person who is a frontline warrior whose age is greater than or equal to 12 or less than 40, that person is eligible. While R6 tells us that if a person's age is greater than or equal to 40, then that person is eligible. So the preconditions are different, but the output is same. Because of the exact reason why that you mentioned, that preconditions are different, right? So for R5 we need to have one extra criteria that a person has to be a frontline warrior, whereas if a person is not a frontline warrior but greater than 40 years in age, then we can directly say that that person is eligible. Whereas if a person is between ages 12 and 40 and also a frontline warrior, then we can say that person is eligible. Yeah, yeah, that is missing. That's right, Khalid. That was a mistake in the written it, so that is true. Yeah, Sanjay, please go ahead. Is the screen not visible to others as well? Uh, Sanjay, maybe you can try rejoining. Maybe that will resolve the issue. Yeah. So yeah, any other doubts about the written it over here before we move on to the questions? Okay, cool then. So let's now move on to the questions. Okay, this is another piece of information given to us. Okay, so initially our working memory used to uh, consist of very small number of elements, right? Now here we have 11 elements in the working memory, and we have to use this along with the net given to us to try to answer the upcoming few questions. Okay, so I would encourage that you take a photo or a screenshot of this particular working memory, because you will going back and forth quite frequently for the next couple of questions between the working memory and the net. Okay, so for easy reference you can take a picture or take a screenshot. Okay, so this is the working memory, and the first question, or the eighth question in this whole session today, this asks us the location of working memory element 201 is in which of the nodes. Okay, so we have to enter the alpha node in which this working memory element information is contained. So I'll go back to the information. This tells us that today the date is 27 September 2021. We have to find the alpha node in which this information is contained. Okay, I'll go back to the net also, and you can tell me which alpha node contains this information. Okay, so I see some of you have already answered the question, so let's go and check. That is right, A9 is the alpha node in which this information is contained. Okay, if you have to verify this from the net, we can follow this structure. So today's date will be contained, the value of the date will be contained in the alpha node A9. Okay, so that answers question 8. I hope there are no doubts here. Question 9 is a similar question. It asks us what is the location of working memory element 203. Okay, so there can be more than one alpha nodes that in which the information is contained. Okay, so in which case you have to enter the label of the alpha nodes as comma separated list in the numerical ascending order, or if you feel that none of the alpha nodes contain that information, you can enter nil. Okay, so I'll go back to the working memory and you can see what information is there. We are told that person with ID Jimmy and age 25. Okay, so this is the information, and you have to tell me which of the alpha nodes is this information contained in. Okay, so if we think about it, a person with ID X, okay, ID Jimmy, that is covered in A14, but we can go a level further down, okay, which will give us information about the age of Jimmy, and that will be 25, so that will be between 12 and 40. So both A18 as well as A19 would host the information that is being conveyed by working memory element 203. Okay, so our answer would be A18, A19. Okay. Cool then. Let's move on to the 10th question now. It's also a similar question. Now this asks us the location of. Yeah, Satish. Mm-hmm. Mm-hmm. No, we'll consider the last level of alpha nodes. Yeah, so think of this in terms of, so I like to think of it in terms of this example. This example has nothing to do with how it is in theory, but I just like to think of it in this way. So think of it as a raindrop trickling down the retinet. Okay, whichever alpha node the raindrop stops on is where the information is stored. So in this case, the information or the raindrop containing the information trickles down this path but gets stored in A18 and A19. Okay, so you report A18 and A19. Yeah. Okay, so I'll show you the working memory element 211. That is second dose for a person having ID Timmy. Okay, this is the 211th working memory element, and we have to find out which working memory or which alpha node is this information contained in. So I'll switch back to the retinet and then I'll let you decide. A nil, that's right. So there is no such alpha node where this information on whether a person has second dose or not is contained, right? So here our answer would be nil. That is, there is no such alpha node where this information is contained. That will be the answer to question 10. I hope these are clear. Sure. So here we were asked the location of the working memory element 211. What was 211? It was second dose ID Timmy. Okay. Now let's see whether there is any alpha node in which such an information is contained. This contains next date of y. This contains attribute next that has value y. This contains date value y. This contains id x. This contains id x. This contains comorbidity present, type first line warrior, age 12. That's right. Okay. 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 I hope that addresses doubts till now. Also, to address one question in the chat box from Hina. So I hope my example on the raindrop trickling down answers your question on whether we can write the whole thing or not. Okay. Okay. So moving on to the 11th question. This tells us the number of instances of R6 and R2 in the conflict set are, which of them? Okay. So like we made a conflict set in the previous example, here also we have to make a conflict set, but here instead of having a few elements in the conflict set, you would have a lot more elements in the conflict set because their working memory has increased. Okay, so I'll leave the working memory image in front of you and let you try to form the conflict set, and then we can discuss the solution. Okay, so we have a couple of answers, and I also have tried to write down some rule and working memory element tuples that we could put into our conflict set, but this needs verification. So can some of you quickly confirm if these are all valid? um, if not, if I've made a mistake, please let me know. I think this would be rule 4, right? Yeah. Is there anything else? Am I missing something? Thanks for pointing that out. Is there anything else that I'm missing out or have put in incorrectly? Okay, seems like this is fine. um, okay, so basically what I did is I took different combinations of these working memory elements and saw which of them can be applied to the rules given to us as per the rater net. Okay, for example, this R1 over here, this can be applied with working memory elements 210 and 201. Okay, so this tells us that first dose for a person with ID Sami, and next dose is on 27 September 2021, and today's date is 27 September 2021. Okay, so that follows this line of reasoning, and we can add this one to a working memory. Okay, so this is an example of firing or selecting rule 1. Similarly, other candidates are mentioned in the right hand side over here. We could also fire rule 4. So we saw rule 1. We could also fire rule 4 with elements 209 and 202. We could fire rule 6 with element 208, rule 6 with 207 again, rule 5 with 206 and 204, and rule 4 with 205 and 203. Okay, so these are the different elements in our conflict set, or rule and working memory element tuples in the conflict set. And now we have to count how many times is R6 being how many times R6 is occurring in the conflict set. Sure. So let's see what is 205. 205 is that person or the person with ID Jimmy, his health has comorbidity present. Okay, and the person's age is 25, which is what is given in 203. Now if we go to our rater net, if we follow this line of reasoning, a person whose ID is given by X or Jimmy in our case, his health is that he has comorbidity present, and his age is 25. So this is between 12 and 40, right? Or just greater than 12. So we don't need to worry about between 40 or something. Then we can make this person as high risk as per this rule 4. That is what is being conveyed in this particular tuple. Does that help? Okay, great. Okay, so here we can count the number of times each rule is appearing in the conflict set, and we will see that rule 6 is appearing once over here and second time over here. Okay, so rule 6 is appearing 2 times. Rule 1 is appearing once, rule 4 is also appearing twice, and rule 5 is appearing once. All the rules are not appearing at all. Okay, so now let's check our question and the solution to the question. Okay, the number of instances of R6 and R2 in the conflict set are: rule 6 appears twice and rule 2 appears 0 number of times, because we didn't have rule 2 in the conflict set. Okay, so this is how we formed the conflict set. we also formed the conflict set in the previous problem. Now the next question asks us to use one of the possible strategies, which is recency, to try and resolve the conflict and select one of these rules to fire next. Okay, there are other strategies as well, like specificity or some other strategies that might be mentioned in the lecture videos. You can revisit and check over there, but here we are going to use recency. Okay, so the question tells us that if the inference engine uses recency as the conflict resolution strategy, then identify the rule data tuples that will be ready to fire. Okay, if multiple rule data tuples qualify, then choose the rule with the smallest index I. Okay, and the last line tells us to answer in a particular manner. We can look into that, but let's look at what recency does. Okay, so what recency does is, first focus on this part of what is written over here. Okay, so let's say we have some rules and working memory element tuples, okay, where the tuples are represented by the timestamps. Okay, so we have t1, t2, t3, s1, s2, s3 for different rule data tuples. Okay, each of these inherently is arranged in the descending order, which means that t1 is greater than t2, t2 is greater than t3, and so on and so forth. Similarly, s1 is greater than s2, s2 is greater than s3, and so on and so forth. Okay, next what we will do is we will compare t1 and s1. Okay, if t1 is greater than s1, we will let this order be. Okay, if t1 is equal to s1, then we will compare t2 and s2. Okay, if t2 and s2 are equal, we will compare t3 and s3, and we will keep going until we reach the last. Okay, if s1 is greater, we will move s1, s2, s3 above t1, t2, t3. Okay, so that is how we will rank the different rule data tuples in decreasing order. Okay, an example is given over here. So here you see that rule 1, this has 210 first, which is greater than 208, which is greater than 207. Rule 7 has 210, which is greater than 202, which is greater than 201. Okay, so each of these have the timestamps arranged in decreasing order internally. Next, we see that if they are ranked in terms of decreasing order by comparing one timestamp at a time, one column of timestamp at a time. Okay, so here we see that rule 1 and rule 7 have 210, 210 at the beginning. Okay, so they are equal. Rule 2 has 209, which is less than 210, so this comes at the bottom. Okay, so because these two were equal, we then move to the next column, and here we saw that 208 is greater than 202, so that appears before. Okay, so rule 1 takes first place, then comes rule 2, and then comes rule 3. Even though this has 208, because the first column at 209, this got the third place because other two rules had 210 over here. Okay, so this is how you will rank all the rule data tuples in your conflict set. Okay, so let's do that. Okay, first of all, is there any confusion on how we do the ranking? Okay, yes, this is the recency test. So when you have the different elements in your conflict set, you will do this kind of ranking to decide which one of them to select as per recency. Yeah, that is also written at the top over here, right? In a conflict set, for two conflicting instances of the same or different rules, recency is decided by listing the WMEs in decreasing or descending time sequence and comparing the ordered list and selecting the dominant one. Okay, so now let's what we'll do is we'll try to rank the different elements of the conflict set as per this recency ranking that we just saw, and then you tell me which of these occurs at the top position. R1, right? So as many of you wrote in the chat box, when you arrange all of these in terms of the ranking that we just saw, because this R1 has 210 in the beginning, this will occupy the first position, right? You can rank the whole set of these things as per your convenience, but you will find that R1 occupies the first place. Okay, because of that, recency will select R1 to be fired next. Okay, so what this essentially means that the rule that is using some working memory elements with timestamps that are more recent as compared to the other rule data tuples. Okay. Another example of conflict resolution strategy would be specificity. In case of specificity, you would select a rule data tuple that would require as many conditions to be satisfied as possible. Okay, that is more specific. That requires you to check more number of criteria before you can apply that rule. Okay, but you can find more examples of that in the lecture slides. Here we have to deal with recency alone. And as the answer says, rule 1 is the one that will be selected to be fired. Note that here you are told to answer in a particular manner. Okay, so you are told that even though we said that ideally we report the timestamps in a decreasing order, okay, 210 should appear before 201, but this question asked us to give our answer in a particular manner, R1 followed by the timestamps arranged in increasing order or ascending order. So this is one point that I would like to emphasize on. Please be very careful in the way you are asked to report your answer. Many times, because we might report it differently, even though our answer is correct, we might not get the full marks or complete or any marks, right? So this is very important. Mm-hmm. Okay, so this here you are not really told how to put your answer. If the question itself tells you how to answer, then you can answer in that manner. Here you are enter the count or the number 0 if the rule is not in the conflict set. Okay, so here as far as I remember, you might have had 2 blanks in which you could enter this way. So usually when the question would expect you answer in a certain way, they will mention a line like this. Okay, so just be careful what they ask for. Yeah, there was a hand raise. Please go ahead. Mm-hmm. Mm-hmm. No. Recency is applicable only for us to select one of the rule data tuples from the conflict set. It doesn't change what rule data tuple we are going to fire next. Yeah, this is selected based on the ranking that we did. Okay, and that ranking we did in a certain manner, but 210 came before 201. But once we have selected that, we can represent this particular rule data tuple in any manner that we want to, because now we have selected it. Okay, here the answer asked us in a certain way, so we just presented the answer in that particular way. Yeah, so I hope recency is clear, and that actually brings us to the end of questions I had for today. Okay, so there is a question by Sushant in the chat box. Okay, let's see the practice assignment. What is there? So which question are you talking about, Sushant? Question 4. Okay, the number of instances of R1. Okay, let's have a look. What does R1 say? That R1 says that if for class slide a block with ID X or a block X with the surface curved at an angle less than 90 degree has color black, and if the base is circle, area is equals to 1, and if the block has name X, then we said it's a wand. Okay, so let's see if how many elements can be put to use over here. So first we are asked a block with a particular name. Okay, so a block name 1, block name 2, block name 3, block name 4 with different owners: Harry, Hermione, Ron and Draco. Okay, so 101, 2, 3 and 4. Okay, this takes care of this path. Now let's look at this particular path. Rule 1 or R1 also requires that the shape of the base to be a circle. Okay, so that is contained in 105, which is block 1, has shape circle and area 1, and 107 block 3 has shape circle but the area is 10, not 1. Okay, so here we have only one option remaining. Okay, so base block 1, shape circle, area 1. Now let's look at the other source of information, which is surface is curved at an angle less than 90 and the color is black. Okay, so for block 1 the side angle is 80, which is less than 90, surface is curved and the color is black. Okay, so if we combine rules 101, 105 and 109, right, there is only one such combination that we could apply, right? That's why there is only one instance of R1 in the conflict set. Although there are other block names, if you include the incoming information from all the sources, all the arrowheads that are coming into this B5, there is only one such combination, right? Why not combine 102? Okay, let's look at what 102 is. Block name 2, owner Hermione. Okay, but we are already told that block 2 has a shape square and area 20, right? But we are told that for us to fire rule 1, shape should be circle and area should be 1. So we can't apply 102, right? You get my point? Yeah. Okay then. Okay, anything else? Okay, so in order for us to fire a rule, we need to have all the sources of information that are coming into that particular beta node to be satisfied, right? Although 1 not 2 satisfies the third arrow which is coming from here, it does not satisfy the second or the middle arrow coming into B5, right? That's why we are not selecting 102. Does that answer your query, Satish? Yes, it's only giving us the name, but yeah, rule 1 also requires that the shape should be a circle and the area should be 1, but we are told that the block 102 contained the information that block had name 2, right? And the block with name 2 has a shape square. Exactly, link is there. Yeah. Okay. Anything else? Which one? The one that we had or the one that... Yeah. Yeah. They should have had a value. It's just a printing error. Yeah. Yeah. Thanks for pointing that. Okay, question 7 in the practice assignment. Let's have a look. Specificity. Okay, so like I discussed one example of conflict resolution, recency. Specificity is another way we can resolve the conflict. Okay, In that case, you would have to select that particular rule that requires us to check more number of conditions. Okay, that is what is being conveyed by specificity. Okay, as the name suggests, a rule data tuple that is more specific is the one that should be fired. Okay, for example, if there is some rule data tuple that has rule 1 or some rule x and only one other data element, working memory element, okay, this is less specific. If it has let's say more number of working memory elements, it needs to check more number of criteria for us to be able to fire that particular rule, right? So that would be more specific, and we would select that one based on specificity. Okay, I hope that answers your query. I'm not solving it in detail, but you can attempt it based on what we just discussed right now. No, not that. Take one rule data tuple at a time and see how specific that is. Not that how many number of times it is appearing. Within each rule data tuple, how many conditions you have to verify before you can apply that rule. Yeah. Okay. Anything else? Yes, in an informal way you can put it that way, but for a more formal definition I would encourage you visit the lecture slides. Yeah. Okay, if no other doubts, then we can end the session for today and let's meet next week. Okay. Thanks all for attending. Yeah. I think it would be difficult for me. I would be conducting 2 more sessions for week 11 and week 12, but yeah, I don't think we would have, or I would have time for a 13th session. But I hope that the other TA might be able to. I'm not sure, I haven't spoken to her, but yeah, if she does take an extra session, that would be helpful. If not, you can check my YouTube channel in which the videos are regularly uploaded for each live session, and for the previous semesters there might have been some extra sessions. I'm not sure if there were, but you can check it once. If there were, then you can refer to those. Okay. Okay. Okay, then see you all next week.